This is actually kind of 3 lectures in one. The first part of the lecture is going over DriveStation because the LUNATECS have had an awful track record when it comes to drive stations. And so we go over this every year so that everyone knows how to manage the drive station because it's everyone's responsibility. Okay? Just like the robot. You see something wrong in the robot? You see something wrong with the drive station, say it. We're going to go over best practices. You can look up these best practices. These are where I'm pulling it from. I'm pulling it from the first site. I'm also pulling it from Chief Delphi. These practices are a bit dated, but they're still true today as they were back then. First, about the drive station, we want a dedicated laptop. Why do we want a dedicated laptop?
So that like, and if it's a laptop that has other things on it, it won't interfere with like the driver station.
That was
What were you thinking?
Because if you have a bunch of other laptops, you can have something important on one and something important on the other, and you can't really focus that much with that.
Okay, I see where you're going with that. Yeah, kind of like what Michael was saying, but a little different. Kind of the reverse. If you have the important thing on the drive station and we're about to go in the field, you can't get to that important thing, right? Whereas, as Michael was saying, you don't want other things on the drive station that would interfere with the drive station. So, what type of laptop should you get? Bare minimum, you want a business class laptop. Those are generally a grade higher than your average personal laptop. You're going to want to have 8 to 16 kilobytes of memory. You're going to want to have gigabytes. Thank you. I'm a little old. I'm dating myself. My little Commodore 64. You want a solid state drive. Why do we want a solid state drive?
Oh, because SSD is a lot faster than hard drive.
That's a good reason.
They're also easier to replace because it's a card and not like this giant disk.
2 really good reasons, and they are on the list. What's another reason that would be on the list?
High definition.
No, but did you want to take?
that you don't have moving parts. It doesn't have to park the heads, so it's less likely to hang around.
Exactly. What happens when you drop a laptop that doesn't have an SSD but has a regular hard drive?
It breaks.
Why does it break?
Because it's attached to it and then it'll break when it falls.
Yes, but specifically, your traditional laptop hard drive has moving parts. Okay? It has disks and it has heads, like a record player. Okay, and those heads, so if my hands here represent disk, my fingers, these are the heads that come out and start reading it. And when it drops, those heads bang physically on the hard drive. And where it bangs, it damages that hard drive. Sometimes to the point where it's irreparable. And we've had that happen at competition. We've had someone just walk into the pit, not paying attention, just walk through the Ethernet cord that's clearly hanging at knee level so they can't see it, right? And they just rip the laptop out of someone's hand, it falls on the ground, boom, it's a dead laptop. And now you don't have a drive station. What happens if you don't have a drive station?
You can't play.
Exactly. So how important is the drive station?
Very important.
Michael, how important is the drive station?
The most important thing when it comes to driving a robot.
I wouldn't go that far, but yeah, it's, yes. So it is a key component to competing. You want to have a large screen, 13 inches. You want to have high resolution. Built-in Ethernet ports, 2 USB ports, 3 if you can, and a keyboard. No need for touchscreen. Why do you want a built-in Ethernet port? Why do you want 2 USB ports?
The Ethernet port allows you to connect to the field management system, and then the 2 Ethernet USB ports are for your controllers.
But what if I have, why can't I have a dongle? Why don't I use a dongle Ethernet?
Oh, that just has a higher probability of not working or breaking, so you need more parts.
So if it's built in, you have a greater chance of it not breaking, correct. And ideally, you would not want one that has the little, I don't know if you guys have seen this on laptops that are thin, but they have a little thing that pops down to do the Ethernet. Have you guys seen that? No. Ideally, you'd want So it's a little thing basically. If it's too thin for the Ethernet, what they do is it pops down and then you can plug in an Ethernet. Yeah, it's like a collapsible Ethernet port. You'd ideally not want that because that's another moving part that can break. The less moving parts you have, the better. So you want to make sure you have a configured up-to-date Windows 11. You want to install all the Windows updates between 1 week to 3 days before competition. So you want to make sure you're up to date with your Windows. If you are not, you could be at competition, and if you don't have this configured correctly, your Windows could all of a sudden decide to update. It could connect to a random Ethernet and say, oh, it's time to update. And now your drive station is out of commission for 2 hours because it's updating. It's just as bad as dropping it. It's just as bad as breaking it. So if we keep it up to date, we won't have that problem. We want to remove, and this is going to sound weird, all third-party antivirus. Windows Defender will be enough, okay? You want to change the active hours for the updates to be off competition. So you have hours where you can configure when you will allow the update to happen. So you can say, do not update between the hours of 7 a.m. to 7 p.m. Only update outside those hours. Does that make sense? And then even if you don't get to this, because let's be honest, how many times did we run Windows updates before competition this year? Programming. We never really got to it. But our drive station was configured never to do updates during the hours of competition. So it never affected us. You want to turn off, put computer to sleep. You want to turn off USB select suspend. What do you think? Why do you think you want to do that? What do you think putting the computer to sleep would do if you happen to be up there driving and it decides to go to sleep? Mm-hmm. What about, does anyone even know what USB select suspend is? No. So that is a part of Windows where it will selectively suspend USB ports if traffic gets too much for it. Or if it has too much activity happening. It will try to suspend a USB port that it thinks it's not being used, even though it's sending traffic to it. Do we all know what a USB port is? Okay. So what could happen is you could be driving the robot and all of a sudden you're no longer driving the robot because your USB port got turned off. That has happened. So you want to turn that off. You want to use a standalone version of Windows 11. What other type of versions of Windows 11 are there?
12.
But that was good.
There's Windows 11 like Home versus Pro.
Like corporate.
Yeah, corporate.
Right. So a home version is what we want to be using. We don't want to use a corporate version that's tied into some corporate network or that we got. And how do we get one of those versions? Someone donates us a laptop. It comes with the previous version of Windows 11 that was on there from their corporate. And you try to log in and it doesn't work. You also want to disable the password login. This will be hard on Windows 11, but it can be done. Why?
Because someone that on the drive team might not know the actual password, and if they need to get on it due to the actual drive team being occupied by something else.
No, he's got it. So what can happen is password changes, someone changes the password, drive team doesn't know the password, only one person on the drive team knows the password. All of these things have happened. Take the password out of the equation. By the way, everything I'm telling you to do here, you never want to do on your computer. Ever. This is a very highly specific use case that you want to configure this laptop for. And that is to drive the robot. And all of these things will help do that. Laptop battery management, ABC, always be charging. Coffee is for chargers. Never not be charging the laptop. This is another thing that we've been very bad about, and we've been lucky. But this is drive team's responsibility and pit crew's responsibility. You see the drive station in the pit, and if it's not plugged in, what do you do?
Plug it in.
You get up, what's the first thing we do when we take it up to the Alliance wall?
Plug it in.
Plug in the charger and then do that.
Right. Always be charging. always have it plugged in, okay? Because sometimes, you know, you never know what's going to happen. Something could come along, you get hit really hard, and the plug pops out. Or you don't have the plug all the way in when you thought you plugged it in all the way, right? And they come along, they pop that plug out, and if it hadn't been charged properly in the pit, all of a sudden the laptop will die. You don't want that to happen. You also want to make sure that the battery can hold a charge for at least 1 hour. So this is something for programming. The programming team will usually take care of this, and we're pretty good about that. That also helps by turning off the laptop, making sure the laptop is properly turned off, and not just closing it and putting it in the packing case so that when a mentor pulls it out to see if it's charged, it's completely dead. Additional things for configuration. We will turn off the Windows firewall. Why will we turn off the Windows firewall? Matter of fact, we'll try to shut down Defender as much as possible.
This firewall can flag the driver station because it's trying to change the function of the laptop. It's like trying to change specifically. I don't exactly know how it works, but all I know is that if it tries to
You're on the right wall, or the right path. Why?
Doesn't it already cause a bit of traffic?
So it in itself doesn't cause traffic, but it will inspect what's going through, and if it thinks it's an attack, it will shut it down. If, for example, it sees the packets coming from the robot as, for example, the image packets, and it says, oh, those aren't important, or that's an attack, it will shut down perhaps the video from the robot, or it will shut down communication altogether. We've seen this happen. This is the easiest way to shut that down, just shut off the firewall. This also leaves your laptop very open to attack. So that's the next thing, turn off the Wi-Fi adapter. Do not allow it to connect to any networks. And when we're at competition, do we need a Wi-Fi adapter? And if we're connecting through the radio, at competition, can we connect over Wi-Fi through the radio? No, we can't. We have to connect through Ethernet or USB, right? So there's no need to get on Wi-Fi at all at competition for the drive station. And we want to have at least one USB Ethernet dongle. Why do we want that? Even though I just said we don't want that. Why do we want that as a backup? Because if your Ethernet port breaks, just in case, right? So we will also have 2 Ethernet cords, 2 USB ports, so that, well, actually we don't even need the USB ports that much anymore, but it's the 2 Ethernet cords so that we have a backup in case one breaks. Or to lend out. Lots of teams forget them. What's up?
Is the blue one the dongle?
No, this is Ethernet. This is the type of USB that we use for the RoboRio. So you can plug in directly to the RoboRio if you have to. And sometimes that's helpful. The last few, I don't think we had to do that this year, but in years prior we had to. We've gotten really good about our Ethernet management on the robot. So before the match, you want to make sure the laptop is on, logged in, and when I say logged in, opened up to Windows. You want to close all programs that are not needed. Frankly, there's only 2 or 3 programs that should be open. The drive station and what?
Elastic, which is like the visualizer for all the data that features match.
Okay, 3. What would be the third? Well, okay, but that's part of the drive station. What would be the third? What's something that we sometimes we...
Limelight.
What?
Google Chrome for our Limelight.
Yeah, Google Chrome for our Limelight. You want to make sure that the laptop is fastened or the drive station is fastened to the Velcro or some other means. So our laptop is not fastened to our drive station with Velcro. It's actually fastened with clips. But the drive station itself has Velcro on the bottom. Why does it have Velcro on the bottom? No one from this side. Anyone from this side.
So if a robot were to, if anything were to knock into the like the area, then the driver station would fall onto you.
Exactly. You don't want to have a robot come and slam into the drive station and knock your drive station onto the ground, right? That you want to make sure that the controllers are plugged into the proper ports with the proper designation. This, I don't know if you guys ever watch Audi or whoever else is setting up the laptop, but they go up, they set up the laptop, they make sure that everything is plugged in, and they check each joystick controller to make sure 1 and 2 are set up correctly. Remember, now you all did that. Remember when you guys set up the drive station, you had to set up the joysticks, you had to adjust them on the drive station? Well, we can, if you haven't done that, by show of hands, who hasn't done that? Because I'm sure there's a bunch of people here who haven't done that. Who has not set up, it's okay, who has not set up the drive station with the robot? Okay, so in the next week, we will sit you down and we'll show you how to do that, okay? It's real simple to do. It's good to understand how it works, all right? All right, general info. You want to have a backup drive station. So we actually usually have 3 or 4 laptops at competition. I like to have a programming laptop, a backup programming laptop, a drive station, and a backup drive station. But usually sometimes we'll end up with 3. Sometimes we'll end up with 2 where the programming laptop ends up being the backup for the drive station, which is always interesting when it becomes the drive station. Again, update software on Wednesday. You want to make sure the drive station software is updated. Now, this only happened to us once, but we went to competition. We didn't have updated drive station software. We had the drive station software for that year, but there was a critical update that happened on Tuesday that you had to put on the drive station or you couldn't compete. If you do not have the proper drive station software, they will not let you compete. Period. So you always want to make sure you're up to date with the drive station software. You also want to have a backup of that drive station software on a USB drive for anyone else who does not have up-to-date software so that you can hand it out, and it's very nice. You want to imagine that there is no Ethernet at competition or wireless at competition to get that software, so you want to have it on a USB drive. Does that make sense? You never want to install programs other than what's required for the drive station. We're bad about this. We're really bad about this. If you look at our drive station right now, it has a ton of software on there that is not needed. And that's partly because we double it as our backup programming laptop, which we shouldn't do. But we are currently doing that. Like the robot, drive station is everybody's responsibility. If you see something that isn't right about the drive station, say something. Okay? And if no one's listening, go tell a mentor. We've talked about this. USB supports, we don't do it. I mean, why would we do something like this? Anybody?
Just to make sure that there's no chance USB can come out.
That, and what else? That's one, there's 2 reasons. That's the first. What's the other one? Yes, so we want to keep it from crimping. So we go, I don't know if USB cables have gotten better or if the C ones are better. I don't know. I feel like we haven't had many problems with USB cables as we have in the past, so this might be a moot point now. All right. So typically at this point, I would have the robot and I would have you all come up and we would configure the robot one by one for the drive station, but most of you, except for 3 of you, have done that. So what I want to do is I'm going to go over what I would also go over at the same time as we're talking about this, okay? Does anyone understand exactly how we communicate and work with the robot from the drive station? Does anyone have a full understanding of that? So basically we have our drive station, right? That has little Atari controllers, right? Little buttons on it. We have a drive station the two controllers, right? It's plugged in through Ethernet, right, at the drive station. Is that so? We all understand that, and that drive station is connected to what? When I plug in this Ethernet to the drive station on the field, what am I connecting to?
Are you connecting to like the field radios or something?
Yes, we are connecting to the Thank you. FMS, the Field Management System. So, what's the first thing we do at what's one of the first things we do at competition with the radio? What's the first thing we do at competition, Lydia? So, who here is familiar with that? I know Lydia is, I know programming is, maybe not all of programming. So literally what happens is when we get to competition, we take the radio off the robot, we hand it to someone, usually someone on programming. So Adi or Lydia will go off and do this. And they will go to the PIT's admin station. At the PIT admin station, they'll have laptops there. And you will plug in. So if this is the radio, we all know this is the radio, yes? We've all seen this before? What? Because this is pulled from the electronics bin, so I'm assuming it means questionable on whether it works or not. And you will walk up to a laptop, and that laptop will have an Ethernet cord. And you will plug in to the Ethernet cord into this. You will type in 316 because it will ask for your team number, and you'll hit enter. And then you sit there, and it will program and encrypt everything on here. So what then happens is, do we all know how this works?
No.
Do we all know how Ethernet works at your house?
Maybe.
Yeah.
So,
Transfers internet.
so you buy from a provider, right? So like Verizon, Comcast, right? And that comes in and it plugs into an to a wireless router, right? You all have a wireless router at your house. Most of you have a wireless router at your house, right? This is a wireless router. This is no different in some respects to the wireless router that is at your house. It broadcasts a signal, and you can connect computers to this. Does that make sense? So it's like an access point. So you can also put a password on it, right? Like at home. You have to type in a password to get on your network, right? Well, they put a password on here essentially. And they do two things. One, they put a password on here, and they also hide the signal. So there's a way that you can have a wireless Ethernet where it doesn't broadcast its identity. Does that make sense? So, are you asking a question? So for example, when I have a wireless, this is broadcasting, right? It will broadcast, for example, what's one that's in here right now? Students, right? SCC students. So SCC students, SCC guests. These are two, if you were to pull out your phone right now and look at the wireless networks, these would be two that you would see. This one has a little lock on it. This one does not. This one requires a password. So you wouldn't be able to get on it unless you knew the password, right? This one, you can just get on. Now, you can also broadcast a wireless signal without announcing to the world that you're broadcasting. And that's what they do. They hide the signal. So they don't broadcast to the world that this is 316. What?
Why does it need a password on it if it's hidden?
What?
Why does the signal need a password on it?
Well, it's worse than that. It actually has an encryption key. And it uses a cipher. I believe it uses a full-on certificate. So you can only connect if you have the right certificate. But why does it have it? Like, why do we prevent other people from connecting to your robot? Well, think about this. let's say I'm in the stands and I'm watching 316 on the field and I go, ooh, I'm going to get on 316's robot. And then I'm going to blast your network with a denial of service attack. So I just flood your robot with pings and data, and it just crams up this access point so that it can do nothing but deal with the data that I'm sending it. What happens then when you try to communicate to your robot? You can't. Or worse, maybe I'm in the stands and I take over your robot deliberately so I can drive your robot from the stands because it's easier to see. So now I have an unfair advantage. Someone who's a better driver, who's not a student, who drives all the time these robots, is up there driving the robot and trying to win the competition. Both of those would be unfair, right? So that's why they encrypt it. And only the FMS has the key to communicate to your robot. So what happens is this communicates to an access point on the field and then broadcasts to your robot. This is, our little robot this year. And it has, where did I put it? This radio on it, right here, so that it can broadcast and they can communicate encryptedly. Only this can talk to the FMS. The FMS is talking to your laptop. Okay? Where does this talk to? So where does this send the signals from your laptop? Well, through the FMS, but it's coming in from the laptop through the FMS to the robot. Where do those signals then go? Because you have an Ethernet on the robot. You all see that, right? We see these things plugged in. So where?
Does it go to the Robo-Rio?
Exactly. As a matter of fact, I'm going to pass this around, and you're going to see on here that there is an Ethernet port on here called Rio. Where do you think that Ethernet is supposed to go?
The Robo-Rio.
To the battery. So essentially you want this kind of setup. This is the Robo-Rio. We've all seen one of these.
Yeah.
And this is the radio. So, here, I'll pass that. And you can see where it says Robo-Rio. So, we know that I have an Ethernet cord on the robot that goes to the Robo-Rio. So this is the radio. This is the Rio. All right. Then what does the Rio communicate to?
It communicates to all the different mechanisms to tell which way to go, but first you would probably stop for the main port of all the connections.
Close. It does talk to all the different mechanisms. How does it talk to those mechanisms? Through what? I know you know. So I have the Robo-Rio. I have mechanisms. What am I drawing here? Motors. All right. So 2 motors for each wheel, right? I'll use green. 2 motors for the mythical elevator that I made, right? So how does it communicate? How does the Robo-Rio communicate to those motors?
The CAN network, but over like the PDA.
The CAN network. Do we all understand what the CAN network is? So imagine this Rio has a wire that comes out and goes to this motor, and then this motor connects, well, motor controller, I'll say, okay? Most of the motors on our robot have both a motor and a motor controller on it. That is how the Falcons and what are the Krakens are designed. But you can have a motor controller and a motor be separate. And this is how Talons will work with, I forget what they're called, but there's other motors that the Talons will work with.
775 Pros.
Thank you, 775 Pros. And they will be 2 different things connected by wires, okay? The Rio is talking to the motor controller. The motor controller talks to the motor, okay? And what happens is the Rio will come to this motor controller, then we run a wire to here, then to here, then to here, then to here, then to here, and then it comes back essentially to the Rio. termination point where it ends, okay? What happens if I cut the CAN network? There.
The last two motors don't work
The last two motors stop working. Why?
because the Rio goes from a motor to motor. Well, it goes from motor, Rio to motor, then motor to motor, and then
Right.
cut that.
So basically, wherever you cut it, anything down from that, the Rio can't communicate with it anymore. If you're curious what that type of network that's called a daisy chain network. You guys ever made, have you ever made daisy head
341.
head things, you know, where you click the daisies together and you make a little crown, the crown of daisies? Has anyone made a crown of daisies?
341.
We got one person.
We got one person. All the daisies are connected to the next daisy in the crown, and if you break that, anything falls off of that.
It has a rope and a bunch of things attached.
Anyway, so essentially each one of these motor controllers is given a number. 1, 2, 3, 4, 5, 6. And the Robo-Rio can say, hey, motor 6, I want you to give power at this percentage or this voltage to the motor that's controlling you in this direction. And it will send that off on the CAN network, and only 6 will respond because it will target 6. It will say, 6, send this motor. But everyone will see that 6 is getting power. Okay? It can also do the same thing with 1, 2, 3, 4, 5, and 6. It's basically, it targets which motor it wants to give power to, and it gives power to that motor. From the motors, we also have the other element which is important here, which I'll draw here. What am I drawing here?
Teammates. Oh, the PD.
The PDH. And
Isn't that what's called? So smart.
so the power distribution hub. What plugs into this?
Battery.
The battery. And then out of here, what do we plug into?
We plug the
Motors. The battery.
The power cable.
Well, the power cables, which is the battery.
More batteries.
But then out of it, where do we connect to this?
daisy chain.
No, we connect all the motors. Like, yeah, I know, but someone else was saying something different than you, and so we get technically they go to the motor controllers, and then the motor controllers send that power off to the motors, right? Yeah. So why do we do this setup?
Positive and negative.
Why is the motor controller in front of the motor?
Because the motor controller controls how much power and where it needs to go.
Right.
The motor.
Does everyone understand that? Annie, do you understand that? Why is the motor controller in front of the motor? I know it's difficult. Try to pay attention. It controls the power that goes to the motor, because the motor controller will tell the motor how much power to give it and what direction to turn. Does that make sense? Now, when I push down on this controller, right, a signal is going to go through my laptop, through the Ethernet, through the FMS, over the wireless, to the robot, to the Robo-Rio. What intercepts that signal at the Robo-Rio?
The Ethernet.
No.
The motor controller.
No.
The battery.
No. What interprets that signal? The what?
The code?
That's right. No, you're not wrong. The code. The code's going to interpret that signal. The code, where does the code exist? When we deploy code to the robot, we literally deploy it to the Robo-Rio. So all the Java code that we program and compile, we put onto the Robo-Rio so that it can interpret the signals from the drive station, and then based on what button you press, based on how you're pushing the joystick, we will turn motors on the CAN network to correspond to what we want to happen. So if you're driving and I push forward on the robot, on the joystick, what motors am I going to control? Drive motors. If I hit A and that's supposed to raise the elevator to a certain height, what motors am I going to control?
5 and 6.
5 and 6, right. How many of you knew how this worked before you walked in here? Kind of.
Kind of.
Kind of a grasp. Kind of. Ultimately, you need to understand how this works, because this will better help you design robots. All of this needs to work together for it to happen. Now, the reason why I went over all that, also I want you to look at this. You'll notice that the PDH, this is the PDH, right?
Going through 3 different names now.
Who knows what this is called? It's PDH now? Okay, it used to be PDP. So,
PDH now.
something else. I want you to notice on the PDH, you'll look, there are numbers. This is important for what I'm about to show you. Take a look. So, the reason why I went over all of that, because that's a lot to digest, is when something goes wrong with the robot, how do I identify what has gone wrong with the robot?
Your silence made me feel less confident about my answer.
How do we identify what's gone wrong?
Logs.
Do you feel better now?
Yes.
Logs. But the logs are hard to read. And you're about to see what they look like. So
You ready for an eyesore?
So, on the drive station is constantly collecting data about the robot. It's constantly telling us how much power is being pulled from the PDP. It's telling us how much packet loss we're having. What is packet loss? Does anyone even know what packet loss is?
I do.
Do you, 6, 7? Is that what you're saying? Mark gave me this. I'm like, what is he saying? 6, 7?
Like how much information it's receiving versus how much it's like understanding of it, something like that.
Sure. So through this communication here, this wireless communication, the data is sent in packets. And there's a way you can, I'm just going to say this, there's ways you can measure whether you're getting all the data correctly, okay? If everything's going smoothly, you won't have any packet loss. If you have packet loss, you'll see things like this. So these particular lines are measuring packet loss. Packet loss means we're not communicating with the robot. We're not communicating, but there's delay in communicating with the robot. It's probably going to be very brief because this is not a whole lot of packet loss. This is kind of standard packet loss, so I don't even worry about it that much. 1 or 2 packets here or there, not a big deal. If I see 10, 20 packets being lost, we have a big problem, okay? So I grabbed our qualifying match from Worlds, 60, because we didn't have any problems. This is actually what a good log looks like. It kind of does, like little, with lightning coming down from the clouds, with weird orbs at the top. So I got to remember what all of these different things are. So. Yeah. So what I'm clicking here is our comms, which is talking about our packet loss and our signals. And then, so up here, actually I want to point this out. Up here, this green line and this blue line, this is time. Okay, so this is when we started capturing data. This is when we ended capturing data. About, what? 2.5 minutes have gone by. What does that represent?
The length of the match.
So if this represents the length of a match, what do you think the green represents? And blue represents teleop. Okay? So that tells us when the match is happening. Do you want to click off basic? And let's take off comms. So, click on power 0 through 3. What is this telling me? Power 40A. 0 through 3. Where is it? There are numbers on the PDH.
Yeah.
So, someone's eyes lit up. 0, 1, 2, 3. Okay? That is showing me, I believe, the voltage of the output. That's what? Ampage?
Yeah.
It's showing the ampage. Thank you. I always get these things confused. I am not an electrician. But it's showing me the ampage that's being pulled through those. So if I see a spike for a particular PDP, what would that tell me? Or a lack of spike, or a lack of pull. Let's say I don't see any power going to a particular motor. What might that tell me? Or a particular...
That the motor might not be working or the power producer is not putting it through correctly.
Could be that. Could be that we have a clipped CAN wire, right? It's not. I can go, thank you. So, no, to go back to the plots. So I can go down and look at each one of my PDPs and see how much power is being drawn. If I see a large spike in ampage on one of my motors, what else could that tell me? Stalling, or maybe it got stuck, so it just keeps trying to move and it's drawing down the battery, right? What?
It may have blown.
Could be a bad, right? Could blown, bad motor controller. Go to, when was Robocon? September what? 8th, right? Go to September 28th. Yep, you're in the right area. Keep coming down. Yeah, I know. All right, so there we have Sunday. I want you to go to elimination match 11. And then do you see something different about this? Before, what did we have up there? What type of dots? What color were they?
Green.
Green. What are they now?
Red.
Hover over them. Device firmware could not be retrieved. Check device ID is correct. CAN range.
Oh, that happens a lot.
Keep going. CAN range, error. CAN frame, too stale.
That happens a lot.
No, it doesn't. No, it does not. Keep going. Like, this is telling me that there was a problem with our CAN network. That there's probably a clip in our CAN network. I believe if we were to talk to pit crew, match 11, we probably had to fix the CAN network after match 11 at Robocon.
It was a problem with the Robo-Rito.
Okay, right. Yeah. So that could have been, that's right, we were sorting out that match. So something was definitely wrong. This should not be happening. And it was affecting our CAN network. So we can look back and go to the event list. This will show us all the bad things that happen. Just a couple.
Oh boy.
The robot's still working, right?
So, lots of bad things happen that much.
This don't look so bad.
For programming, this means a lot to us. This tells us things that are broken, but if the RoboRio is really busted, everything kind of looks like it just blew up. And that's kind of what this match looks like. Through looking at this data, we can immediately identify that something is wrong, but specifically, if there was a broken motor, we could identify a specific motor that's broken. Does that make sense? We could also see, for example, I don't see if we see it here, but brown circles at the top as opposed to red circles are brownouts. So you can see, does everyone know what a brownout is? No. Okay, so brownout is where we stop communicating with the robot. The robot, for whatever reason, doesn't communicate. There's basically a short or something, and the robot stops responding. And that is a brownout. It's not a blackout because it's still communicating afterwards. Does that make sense? And usually that can happen through a lot of reasons. CPU usage. Matter of fact, oddly enough, we ran into a problem where we were getting a whole bunch of packet loss, seeing a lot, and packet loss will also result in brownouts, where we're seeing a lot of brownouts. And the problem was our drive station CPU, I believe, was running a scan for Windows Defender. This is why we shut off Windows Defender.
It's not defending much.
So, does anyone have questions about this? It's a lot. I understand it's a lot. I wanted to show you how everything communicates, because through these logs, we can see various parts of this, right? So we see the communication that's happening between the robot and the drive station. We see the CPU usage on the CPU, on the drive station. I believe that's one of the toggles you can have. We can see the CPU usage on the RoboRio. We can see, so the way we program our robot for everything to execute within, what is it, 20 nanoseconds, milliseconds? Everything has to execute within 20 milliseconds. And if it doesn't execute within 20 milliseconds, we get an error that says, hey, you have something that's executing that's taking too long in your code. Make it go quicker. Yeah, so that is what logs look like. And through this, we can diagnose what's going on with the robot. And actually, if you ever talk to, what are the guys called? You know who I'm talking. FTAs. FTAs will come in, they'll look at this, and they'll see exactly what's going on with your robot. So we're not there yet. We're still, as a team, we're still learning how to look at these logs. We have to get better at this. This will help us identify problems quicker with electronics. This will help us get better at identifying problems with the drive station, with communications, with code, even mechanically.
I was noticing, so I know that we're using two different images for this, but the red line is a lot higher in this image than it was in the last image. Is there no reason to that?
This is the one where it's erroring out.
Yes.
So at this point, the computer, the RoboRio, is just losing its mind, catching up with all the errors, logging them, and sending them.
I believe that's the red line is the CAN network, if I'm not mistaken.
It says RoboRio CPU.
Oh, yes. So yes. It went up a lot because it's trying to do a lot more. And it's trying to process a lot more problems that it's seeing, right?
And then there's a spike in the volume.
So that's things that we would, I mean, this is an easy one. You look at this and you're like, all hell broke loose. It gets really insidious when it's like all green and then you have a few brown dots and you're like, what's going on with those brown dots? Because the brownout could also be the result, can be a result of the battery being too low too. And it's not enough power to charge the robot and move it. So you get all sorts of things.
This might be a stupid question, but what computer is this based off of? Like, what computer do you run this on? Do you use it on the drivetrain, or do you use it on the computer?
So all of this data is coming, where's the, okay. All of that data, most of the data, I won't say all of it. So all of that is coming from here. So this is, does anyone know what a Linux system is?
Okay, I've got one right. Show off. Show off.
So we all know what a Windows system is, right? So do we all know what a Mac is? Macs runs, they technically don't run Linux, but it's a flavor of Linux. So this runs a similar operating system to a Mac, okay? It's Linux, it runs a real-time operating system. Do we understand what a real-time operating system is versus your PC? So a real-time operating system is a system that runs basically real-time computers. Your car will run a real-time operating system. Robots run real-time operating systems. It's basically designed to not work in kind of a scheduling means, but work in a continuous means. That's not a great definition, but it's the best I can give you. So it's using a real-time Linux. You can connect to this and get on and get onto it, and you can look at the files. You can see where our code is placed on here. You can get to log files that we can put on there. There's lots of things we can do with this. It's a lot of fun. We also have to make sure that we don't fill it up with space, because has anyone had their Windows machine have too much space on it, like used up too much space? What happens?
My computer's very slow.
Your computer is very slow. So why is your computer very slow when that happens?
Because of memory.
Well, it has plenty of memory, but there's also something called swap space, where it puts stuff on the hard drive that it's not using at the moment. And so like if it has some stuff, it's like, oh, this is some stuff that I was working on, but I'm not working on right now. I'm going to save this to the hard drive, and I'm going to focus on all the stuff that I'm doing right now, right? Linux does the same thing. So when it starts using up too much memory, and the memory's getting low, it says, oh, there's some stuff over here. Maybe hypothetically, I'm driving the robot right now, so I want the drive code up in memory, but maybe this is not exactly what happens, but visualize that this could happen. You know, I'm driving, I'm not using the elevator, so the elevator code gets put to disk. And basically, if it doesn't have the ability to swap to disk, it's going to start thrashing. And when it thrashes, it starts slowing down because it doesn't have enough space on here. So, any other questions? All right, there will be an exam on Thursday.
Wait, is there like a study guide?
No, your notes.
What notes?
Go ahead.
Can you release the slideshow? Are you going to release the slideshow?
Sure.
That's probably not going to help, actually.
You only get a minute to look at it.
Yes.